Now we look at another nonlinear model for real-life behavior. We're going to look at a logarithmic model. And we'll begin by looking at the shape. So the shape of a logarithmic model is it does grow over time, but the rate at which it's growing slows down. So the growth rate slows. So if you were to look at that, it does this sort of thing. It starts off growing pretty quickly and then it starts to level off. Now it never does actually level off. It continues to grow just really slowly. The equation or the function for a logarithmic model, there are lots of different logarithms, okay? What we're going to talk about in this video is a function that has what's called the natural logarithm, okay? And so the natural logarithm is the ln. ln is the natural logarithm, okay? Now, let's take a look at a particular example that could exhibit this type of shape, and then we'll connect to that a function and do some calculations with it. So one type of example could be what is the year, like what year it is, how does that impact your life expectancy? This is a good example. How does the year impact the life expectancy, the average life expectancy? So if you were to look at a graph or a scatter plot of what this might look like, you could have the year on this axis, and on this axis you could have your life expectancy, and you would imagine that over time your scatter plot might do this kind of thing, where life expectancy should get better as technology improves, food improves, all sorts of things, and life expectancy is going to get better. However, it's not going to grow rapidly after a certain time because humans can only live so long. So it's going to start to flatten out, okay? So now that we've seen a scatter plot, we could use mathematics based on this particular data in this picture. Sorry, I forgot to list life expectancy on my y-axis, okay? If I were to look at a function or a curve that models this particular data, it might look something like this, okay? And so if you look at a model using a graphing device for a curve like this, it might be called ln-reg, for natural logarithm regression. And so I've already done that part where I took some data involving life expectancy, and we've got our natural log regression model to be this. It's going to be a plus b times the natural log of x. Now, one thing I want to mention is the year here is the x values aren't literally the year. So when I say year, what we're going to do in this case is we're going to say x is number of decades since 1900, okay? So for example, if x is 1, that means that we're in the year 1910. If x is 2, then we're 2 decades, 20 years since 1900. So we're talking 1920, and so on. So for example, if x were 5, we'd be talking about 1950. So this is a common practice where you don't actually use the year as your x value. You translate it to be a nicer x value to work with. And that's what this model here is assuming. So this is the model, but we have to know what the constants a and b are for that particular curve. So in this case, relating the year to the life expectancy, it looks like a is 42.527 22583. And B is 13.857 52327. Okay? So this is our logarithmic model to represent this curve as a model for the actual scatter plot data. Okay? So let's rewrite our model in a way we might actually write it down. So I'm going to replace A and B from the equation we just had. So it's A, which is 42.52722,583, plus B, 13.857,52327, times the natural log of x. Okay? So that's the model we will use to answer questions. So I could ask, for example, what was the life expectancy in 1940 according to this model? So all we would do here is, if we look at what we know and what we're asking, we know what year it is. So that means we know our x value. And if the year is 1940, then we're talking about an x of 4 decades. So x is 4. And we're asking for what the life expectancy is, so we want to know what y is. So now we're going to take our model and we're going to input for x, we're going to input 4. So I'm going to put ln of 4 right here. Now on your scientific calculator, you will have an ln button somewhere. So make sure you locate that. And now I'm just going to type all of this in. So 42.52722,583 plus 13.857,52327 times the natural log times the ln of 4. And it looks like I get an answer of about 62, and that's years, because it's a life expectancy. So according to this model, in 1940, the average life expectancy was about 62 years. Now, let's use this model to make a prediction. What will be the life expectancy, let's say, in 2040? Of course, that's assuming that this model continues, right? That's the idea with modeling, is you assume it continues and you make a prediction based on that. So in this case, if we're talking about 2040, well, that's 140 years after 1900. So that's 14 decades. So now I'm going to plug in 14 for x instead of 4. And I've already got this function typed into my calculator, so I'm going to go use my up arrow to reuse it, and I'm going to replace that 4 with a 14. And in that case, it looks like we're looking at approximately 79 years. So the life expectancy, according to this model, should be about 79 years in 2040. Great example of a logarithmic model. The hardest part here is writing all these numbers and not missing one or having some sort of typo. So just be careful with that.